record, and this one, and now of course it will be in presenters mode. Yes, and I need to press here. Now I learned it hard way. Yeah, hi. Again, to those of you who had a course with me last year, and I guess there are some new people. So, are there anybody who did who see me for the first time? Okay, good, good. Then it will be something new to you. Hi. I will tell you a story. I ran this course. Let me say, maybe for past 5 or 6 years, and this was the first machine learning course which I developed for the SRT department. Now we have the whole spectrum of it. I have to admit, I still do not have a consistent view on the technical content, and how it's all fit together. And but specifically to this course, so this is an advanced level course, and it used to be a very intimate course. Why intimate? Because I developed it for 15 students only. So first 3 years, I guess, I ran it for 15 students, and then it became popular. So I got more. So it was totally optional for the program students, for the normal data technique students. And then it became kind of popular. So the number of students rise from 15 to maybe 25, something like that. But this year is a very special one. So this is the first year I run it for around 90 students, because of this 2 master programs and the regular data students that take this course. And so voila, here we are. And it means that I needed to introduce some changes, so I will tell about them in due time. But for those of you who, let me see. Oh no, I removed the slides about myself. Who didn't meet me in previous courses, I can tell that, well, my name is Evgeny, so it's a Russian name. And I work here at LTU since 2007. And before that, well, actually, I live in Sweden since 1999, for quite a long time. And I worked in quite many interesting places. Studied, did research, including Switzerland, like EPFL in Lausanne, University of Basel in the German part, RWTH Aachen in Germany, KTH in Stockholm, SIX, which is now RISE in Stockholm. And finally, I accepted a position first as lecturer here, and then I was promoted all the way to professor. So, and so it was a long journey to the north, so to say. But also I transformed even my research focus from being more of a telecom researcher, so focusing on the internet communication networks, wireless communications, to low-level wireless sensor networks, which is now known as Internet of Things, such things. And at some point, like maybe 15 years ago, I
Excuse me.
Yes.
Do you share any screen or something? Because we can't see that.
You don't? Yes, thank you. Okay, that was very good timing. Let me see. No, I don't share the screen, obviously. Thank you. But you could put me on a full screen, at least. Yes. Share screen. Yes. Now you do see my screen, right?
Yes.
Cool. Thank you. And please tell me if you see something that you don't expect to see on the screen. And even please remind me if I forget to start recording. Sometimes it happens. Yeah. But all in all, somewhat 15 years ago, so I came to understanding research-wise that communication really is the bottleneck for such technology as Internet of Things. And I was in search for some novel computing approaches to make more computing at lower power on the devices. And I came across one interesting theory or computational framework, which apparently was part of artificial intelligence. And that was the start of my AI journey. I will tell you more about this research area because it is very directly connected to the agenda of this course. Yes. Yeah, but that's enough about me. And I structured this course in such a way that's kind of maybe repeating some known to some of you approaches, but going deeper into details. So nowadays, or presently, is the in what matters AI development. It is the time of development frameworks, right? So you take Torch, scikit-learn, whatever. So all machine learning boils down to connecting a library, selecting a model, selecting a data set, and pressing the execute button, hoping for that everything works fine. So in this course, we will go through some, well, we will start from some basics, but then quickly ramp up to some more advanced mechanisms. And the focus will be on hands-on experience. So towards the middle of the course, and even towards more the second half of the course, you will be developing, or I will ask you to develop certain algorithms from scratch without using any frameworks. So basically, so now looking a little bit ahead, so you will be given a research paper describing a neural network architecture, and here you go. So this is your starting point. So, and looking and jumping ahead, so that is the most time-consuming lab, and I put it towards the end, so to spoil your Christmas and New Year. Yes. Course material. You see, a good book is, of course, this artificial intelligence modern approach. It's a good book, a textbook, but it doesn't give you all the details. So it's a good overview book of main approaches, and I recommend you to read it. To pass this course, however, you need to do more extended search. So some of the material I will give you in the lectures. Google is, of course, of help. MOOC courses like from well-known universities, Google, Facebook, etc. So they are, of course, super good. So I mean, it's hard to beat them on the presentation. So whenever you want for kind of a second opinion or explanation, so you always can. And moreover, I will give you some links to the relevant courses, especially with respect to deep learning and data pre-processing. And by the way, so this course is not about deep learning. I will start next class tomorrow, by overviewing a landscape of what is known, a landscape of ML/AI. So the only thing I mean, I can tell now that this this course focuses on learning. So if last year, those of you who took this the last year course, it was focusing on data representation more and more on symbolic reasoning, like how to work with ontologies and such. This course is really about learning. And I also, I mean, as a red thread, again, I don't know, I don't know your current background with respect to machine learning AI. By the end of the course, I want you to form your own opinion, really, even on the level of definition. So some people tend to kind of separate these two, kind of machine learning, AI, like two different things. In my understanding, they are all about, or at least those solutions, algorithms that are currently sold as being AI, so they are actually still machine learning style. So, but today we will be talking about the differences. So here is the layout. So as I said, so first two classes tomorrow and next week we will be reviewing some basics of machine learning, classical machine learning. And there is a great deal of meaning behind it. First of all, in what matters evaluation of performance. So I mean, you may think it's obvious, but at least it's worth to be reminded of if you already know even. Data pre-processing, believe me or not, well, I guess, I mean, it's not a question of belief, so it's a fact. Data pre-processing is the most important step in AI/machine learning. If you don't work properly with your data, so you shouldn't expect good results as the output. Then again, so tomorrow I will talk about different machine learning algorithms, concepts on the level of definitions, but such things as singular value decomposition. I mean, this year I will not be, I won't be talking about it, but just to name it: singular value decomposition, principal component analysis, support vector machines, kernel methods. So all the body of knowledge which was developed under the umbrella of machine learning, it's indispensable. So again, don't take it personally, and actually I'm not intent to generalize it, but I just see it as a trend, and it's okay. It's not a maybe super bad trend, but in the presence of these frameworks, so people, you know, tend to jump on deep nets immediately, like, you know, program solution starting from deep nets, you know, interface your data with deep nets and hoping for the magic. But apparently, and again, I will reiterate on this message, if you cannot train a simplest model, and what would be the simplest model? Machine learning model. Can you name it? Name a simplest model. Huh? KNN. So if your KNN doesn't work appropriately on a given data set, you shouldn't expect that neural networks will do much better. I mean, well, it will do better somewhat, but again, to understand how much better, so you still need to kind of have a baseline with some basic methods. All in all, if you now read research papers in the area of again, so I will talk. I will use this words interchangeably, but say AI. So more and more techniques from machine learning, which somehow was obscured or even forgotten maybe some 10 years ago, they come back in the context of neural networks, of analysis of neural networks and such. And therefore, it is of ultimate importance to be aware of this methods, at least. Yes. Then we will be talking about NLP, but again, so this course is not about NLP as such. So I think Marcus has a course on NLP, so just dedicated to NLP. So here again, I want to contrast different ways of producing embeddings. So embeddings are extremely important. So even today we'll be talking about in the context of AI as a discipline, because this is the bridge to symbolic operations somehow, and embeddings are something that you learn. And then again, back to neural nets. So I selected a class of neural networks, basically self-organizing maps. Did you work with them? No? You know what they are? No? Good. Something new. Recurrent neural networks, there can be different flavors of it. So in recurrent neural networks, here we will be talking about a special kind of neural networks, which is known also under the name of reservoir computing. So we will be talking about so-called echo state networks, and so something new. So, and again, the idea here with the neural net module is to show a little bit the diversity of neural nets. And then the backprop neural nets. So again, so here the focus to me, I think it's of ultimate importance to really understand the math behind backprop. Even if you had this class before, maybe it will be good refresh of the knowledge. So some of the classes will be on, well, here it's written whiteboard, but actually I'm using this Remarkable, so it still will be streamed in Zoom. Okay, and it is actually connected to this lecture 9. So we will have a lab where you will implement the entire architecture from scratch. Yes. So here it is. Here is the layout. Again, so the point with today's class is to give you a little bit of overview. I mean, all this information is summarized in Canvas. I hope you all visited Canvas. But I still want to recapitulate on main aspects loud, so just so that we are all on the same page. And I also to highlight the changes. And the changes will be, so there will be some new stuff with respect how we will handle labs, and we will do seminars this year.
Question?
Yes?
Is it possible for you to upload your presentation beforehand? Because I can't find them on Canvas.
I will try, but not handwritten lectures. If I will have PowerPoint, yes, I will upload. But the thing is that, you know, it was, I don't know, maybe I mean you're an exception, but most of the people I do the last changes the very last minute. But I will try. I will do my best. So examination moments, labs. So we will have 6 of them. Seminars and a mini project. So this is no. So there is no written exam, no quizzes in this course. So mini project is the this course adopts continuous examination form. So you collect points in different moments, and then I set the grade based on the points that you collected. Yes. Labs. This year, so this is the change compared to the last occasions of the course. So previously, when the course was small, so I did oral assessment of labs with students. Basically, not lengthy, but just to check the understanding of the main aspects. So in this format, with 90 people, this is not very sustainable, and most likely it doesn't add anything to the quality of learning. So I will try a different approach. So basically, I introduced 2 deadlines, hard deadlines. So one deadline is November 24th for labs 1 to 3, and the second deadline is December 15th for the labs 4 to 6. And after these days, so the assignment will turn to pumpkin, meaning that it will disappear. So you won't be able to submit the report. But so this year a report is enough for assessment. So I will go through reports and check them. About the reports, what is a report for labs? So report should contain all the illustrations needed to show intermediate steps. So you have an assignment, so you need to document your progress through intermediate steps, so that it is visible and easier to spot if you did something. I mean, if there are some errors also. Once again, it's not a point to maybe prosecute you for errors like bad accuracy, for example, for training on trainings, say self-organized maps. It's more about that you understand what you are doing, and then yeah, and hopefully you should, I mean, as part of self-assessment, you should say, I understand that something is going not correct. So you can work in groups of 2, but each person from the group should submit a report. So it can be the same report. Seminars. See if I can find it. Seminars. So this is the second moment where I introduced major changes. So actually, this course moment has transformed from traditional seminars where I gave papers to students, and then they, I asked them to present in front of the class. That was not very exciting, so to say. I mean, half of the class fell in sleep. The other half, well, didn't follow. I don't know. It wasn't very exciting. So the most successful variant of seminars was over the past 2 years, maybe 2 or if not 3 years, where I organized a mini conference with posters. Why am I telling you? So just to see the transition. So this year it will be slight modifications of the second concept. And the idea is was twofold. First of all, to make people move between the stations all at the same time. And secondly, so to model this kind of poster session at the event on international conferences. But again, with 90 people, half of whom are online, the other half is inside. This concept doesn't work really. But I still want to have it more interactive, so to say, and less formal. But we move. I want to try something new this year. So it will be online and still along the steps of international conference. So you will be given a research article or articles. I will come up with suggestions soon, so they are not ready yet. I split you into groups randomly. So some of you, I mean, the groups can be, part of the people will be available remotely, part on campus. And then collectively, you need to read these papers and work on a presentation. And then what you will do, so the group that work on the presentation, you will be responsible for organizing this kind of special session. Yes.
Can the assignments to groups take into consideration the lab groups in order to ease the logistics of the
Logistics like what?
logistics of the actually creating a content? Because if we are 4 people from 4 different lab groups, it's a bit worse than.
And those are different programs, different classes, in different countries, different time zones. So how to arrange
Exactly. So that's the part of the challenge.
What is the purpose of it? What do you gain from having?
Why do you need to have a purpose in everything? No, but seriously, what is the purpose? Well, the purpose is, I mean, in many practical cases, you work across different time zones, and you work remotely, and so that would be a purpose to. Yeah, if you say, I mean, how this purpose is connected to the technical content. I don't know. Maybe it will train your AI or true intelligent capabilities for coordinating activities. I don't know. No, but seriously talking, I don't know. Yeah, if you are, it is like this. Any decision always have, people who may be less like it than others. If you all say that we should do something differently, we can do. But your decision, it creates, or your suggestion would create maybe logistical nightmare for me to form these groups.
After every decision, there are.
Exactly, and that's why, since I was supposed to suggest the decision.
But why can't we just choose our own?
Huh?
We can choose our own. We know each other's schedule. That's good.
I will come back to about it tomorrow. Let me sleep on it.
But Jenny, like these groups we're discussing now, they were only for the seminars, right?
Yes.
You had 1 or 2 seminars?
No, you have no, you have many seminars. No, you have as many seminars as number of groups. But I just to kind of reduce the burden of kind of attending. Yes.
But if you go back to the picture where you have the schedule of the course, this one, it only says seminars in the end, so all the different groups here are supposed to run their seminars
Yeah.
within this time frame.
Yes.
And everyone needs to show up for them. Okay, so how many seminars would, or how many
So,
groups? would-
Look, so this is my suggestion. So as soon as groups by some means will be formed, so the group in question who prepares the presentation takes care of scheduling seminars within a given time frame, and so there will be a number of groups for whom it is mandatory to attend the seminars of this group, the presentation of this group. So DLS, but it's not for everybody. So I will come up with the distribution of groups as soon as the groups will be formed. So, and it means, and the group that gives this seminar should agree with the peers that, okay, so we meet on this time. So you do it by Doodle or something. So you agree on the time, and then you post the date when this seminar will happen.
Yep.
All right, so that others, if they're interested in this topic, also can join, and including me. And just in case, if just to account for the case that I cannot join maybe at a certain time, so you will be responsible for recording this seminar and bookkeeping the attendance, and then make it available. So let's see how it works. Any objections on this decision? Strong dislikes? Well, I'm looking at you. Yeah, okay. Yes. Huh? No?
No, it's good.
Okay, good. So that's nice. Right. The grading is yeah, it's quite straightforward. So I mean, they all summarized in Canvas. So if you have some specific questions, so please use our main communication channel. So this year, after so many, and especially the last year, you know, complaints from, I mean, your group, so I finally, you know, gave up. So I changed Microsoft Teams to Discord. Woohoo! Yes, actually, I mean, I still don't understand what's the difference, but okay, I like it, so it works. It works, and so did all of you access the or subscribe to the server? Are there anybody? So the link for subscription is in Canvas. Oh, I see already. Yes. Once again, maybe a lyric deviation. Let me just show you why it is main communication channel. So I guess so. Those of you from last year, so you probably see the increment. So this is my mailbox with the number of unread emails. There is a story behind it. I mean, if you think that I'm inefficient, well, maybe I am not. But I tell you the truth. 10 years ago, no more. I mean, when I started to work here at LTU, I took 2 courses on personal efficiency. And it was a dude who taught us on how to sort emails and such. And then I followed it for, I don't know, some time. But then I realized that the search engine it works perfect for me. So after that, I gave up. And you know, the nice thing of being professor, they cannot deny me increasing the quota. So that's why. But the downside is that the probability of your email, you know, ending up in this huge number of unread emails is also non-zero. So, and that's why I actually, I mean, well, it all started in Corona times, and it worked perfectly since then. So previously it was Microsoft Teams, now it's Discord. So I find so you may expect me way more responsive on this tool. But also those of you who didn't attend my courses previously, maybe as an example, I want to show you. You know, Discord server from another course of mine, so computer and network security. I encourage you to. I mean, it's not that I encourage. I almost demand you to use this tool for internal communication. So, especially when it concerns labs. So you post a question, so you come across an issue, even kind of understandings or misunderstanding of some formulation, you post it on Discord, and here there are 2 options. First of all, I expect, or here I encourage. I encourage you to help each other by responding or resolving this trouble ticket. And as a motivation, I have this good fellow points. So extra points I give by the end of the course for active resolvers. And you see, normally it works, and so I also intervene when the discussion dies out somehow, or I mean, it really concerns a certain question concerns me, so I comment myself. But as the live shows, students, well, students, I think, yeah, students is your current professional quality, but you are a collective mind talking about intelligence, and you come with different backgrounds, and you have different paces of solving and working on problems, and it's totally fine to help each other. So it doesn't reduce, it doesn't take any opportunity to gain knowledge for those who ask the question. So that's why I think it's a proper mode of communication. Moreover, talking about AI and AI-based systems, this is the way how our interactions with technical systems are, the paradigm is changing. So now with the appearance of ChatGPT, we are not searching for answers. So we are kind of learning through communications. So this is, if you think about the really big change of paradigm. Yes, so Discord, I said. Yes. Any project? Mini project. So here again, the idea from the beginning was to give you kind of free hands to work on whatever you like. Hopefully, using the techniques that you develop in this course, not limited to that. So here you may even think about applying frameworks, but again, so I don't put any restrictions. So I have some specification of target functionality. What kind of requirements it needs to satisfy. So you basically decide, so what is kind of cool to work on, together with select data sets you work on. Or maybe you work on your own data if you know how to do that. And then you implement it. Do the entire chain of work, starting from data pre-processing to learning to statistically proper validation on statistically significant to achieve statistically significant results, etc. A good project is about using several data sets. Yet another criteria would be maybe to select a challenge, some AI ML challenge available from in the internet, and try to solve it somehow. Well, it can be anything. So people throughout the previous occasions of the course, they developed AI-based engines for games, and again, so it wasn't a super duper game, but it was like a consistent piece of software. So it was like a snake game learning something. So text processing, speech processing, so text and speech processing, like data fusion. So again, open your mind. So think about what is kind of cool to work on, and select the topic appropriately. Shall we take a break? Couple of minutes.
I have a quick question.
Yes.
Was the mini project, was that solo?
No, it wasn't. No, you can work in groups. I think I have written it somewhere. Group of 2 is a kind of most efficient group. 3 maybe still acceptable, but not more than that. You see, the requirements can, or it really depends. If you say we are 4 people, but we have an ambition to develop this, and that, and then you say, so that's really kind of work for 4 people. It's okay, so we can discuss. But otherwise, 2 to 3 people. And then, so it will be peer assessment. So you will work on the project until the last week of the course, which is in January. So prepare a presentation, make your code available on GitHub, make sure that it is compilable, so the test is run. And then people, so normally 2 other groups or students will verify it and write their opinion about it. And then I go through all the recordings and see the opinions of students and do the final assessment. Yes.
Very preference to use GitHub instead of, for example, Kaggle or something
Huh?
like this. Kaggle, like Jupyter Notebooks.
Kaggle. No, I mean, again, last year we used GitHub simply. I mean, we need to use some common tool.
Because they use GitHub.
Yes, use GitHub.
Okay.
Yes, use GitHub. You know, you always need explanation. So I'm starting with finding explanation. Why GitHub? I don't know. All right, let's take a break. 3 minutes leg stretching.
Jag vet inte ingenting. Fan, jag vet. Jag tar bort det här.
A question, Jenny.
Sure.
What decides like a correct mini project and not?
Nice.
Okay, like
the criteria will be published, or they are already published. I will double check. So
Yeah.
check on Canvas. So the project needs to satisfy certain set of requirements. How large is hard to say. So it needs to have to achieve. But it's a good question. Let me
because
see.
I work on a project on the side, and if I can like
No, actually, I prefer to. I prefer not that you not to, combine this project. But again, it depends. So, what kind of projects? We can discuss. So, what kind of projects you have in mind?
well, it's an app that could take bird sounds and then classify which kind of bird in Sweden is. So I take in an MP3 file and convert it to maybe a picture or something and use CNN to classify it, I guess.
And in what context are you working on this?
It's a project group in the last course we take as in our master.
Which is you mean
Yeah.
like
Interactive design. Yeah, it's a big big project, but I am like in charge of the AI. So if I could put more time into that and use that as a project, mini project, it would be nice.
But
We can talk. We can mail about it. It's maybe easier than take now.
I just want to see if I have some more information. Yeah, so here it is. I can comment to for everybody.
Because these will work pretty good in my project, I think. That I test a lot of different CNNs to like classify sounds and thereafter make a
Yeah,
good
but
existing model.
but you see, so just to be sure that it depends, depending on what your so the complexity depends, for example, how many data sets you use, how many models you try, so how well
Yeah.
you you see. So maybe just reflecting on what you said, just working on bird sounds is so it would qualify as a single data set.
I can, but in this app I also do classification of bird pictures also. So if I could, it both pictures and sounds, and then classify the type of bird it is.
Pictures and sounds. Okay, but we need to you need to probably write it up a proposal. I mean, kind of.
Yeah, of course.
With respect. Yeah, I will comment on this now. Shall we resume? There was a question which I think is still good to comment on before we continue. Regarding the mini project. So let me double check. So the starting point was how large the project should be. So how large is very is not probably a very quantifiable question, but rather, so I define this criteria for grading, and I don't know. I think there is a of different motivations for that as well. So even from pedagogical point of view, but I kind of depending on what grade you target, so you may choose the complexity of the project. So and basically the higher grades assume the requirements of the previous grade. So for example, for grade 4, so you need to perform an extensive set of experiments and evaluate the performance of a single model on the chosen use case and compare it to 3. And here, so the model is something that you create yourself. So here for grade 3, so you select maybe a pre-trained model and do evaluation on accompanying data, but again, systematic evaluation, so with respect to accuracy. For grade 5, so you need to evaluate the performance on several existing models on the chosen use case. So basically, so you have a use case in mind, and you try to attack it using different machine learning methods. So as simple as that.
And if we use neural networks, can we use like or do fine tuning? Also, as in using a pre-trained model and then extending it and then fine tuning.
Yes, you mean like transfer learning?
Yeah.
Sure. Yes, obviously. Yes. Then I mean, yeah, it would be. Yes, absolutely. Yes, you can do it. Right. So let me see how much time. Let me skip over some slides. Yeah, maybe let me just do a very quick rearrangement, looking at time we have. So we start with this fundamental concept of intelligent agent. So an entity which is placed inside an environment. So artificial, yeah, we are talking about artificial intelligence. So it's artificial created entity placed inside an environment, or an environment here again. So this is a generic concept. So it can be like a physical environment, like in space/time. Or it can be a virtual environment. For example, so you take universe of the internet, World Wide Web, so with all the information you have in there, so which also possesses properties of the environment. And so this entity in itself, so I mean, it becomes so it starts to possess principles of intelligence only in the context of the environment where in which it is placed, through interactions, constant interactions with the environment. So, and these interactions is bidirectional communication. So you sample an environment via perception system, so sensors, and then you affect an environment via actuators. And again, so you close this loop by observing the changes, the reaction of the environment on these changes, again through the sensor system. And then something is happening here inside the agent that makes it makes this agent an intelligent one. And so that's what so this functionality that exists in there, so it possesses this properties so which are listed above. So I will not go into details spelling out each and every one of them. But the important point is that so the agent needs to be able to conceptualize the environment. So it needs to learn certain patterns and dependencies in the outside world, and use these dependencies in the decision-making process. And again, so this decision-making process in turn, it should be kind of a goal-oriented, and it should be modulated by the environment. So there are lots of kind of non-determinism in this process. So we will be in this course. We are concerning really learning part. So we are less concerned about decision making capabilities and reasoning, but really conceptualization. So learning stuff. Then the important property again of this device over here, if we talk about AI systems, so and actually that's what makes it different from really the ML systems, is that this process of learning or is a continuous one. So so all the processes about a reflection on the environment, conceptualization, reasoning, acting upon the environment, and doing it again and again. So that's what kind of closes the loop and allows a system to become intelligent. And that is known since pretty much long time ago, as stated here. So, and again, so in the difference between AI and ML is in the type of problems that we consider. So the AI algorithm is non-deterministic, so it's really, and it doesn't have the stopping criteria, while ML, it has really well-defined stopping criteria. So it is created to solve a specific task, and as such, most of the problems are most of the solutions that we have now, and which kind of packaged under the name of AI, they are still kind of narrow purpose problem oriented solutions. Another thing which is important to another concept again important to be aware of is the curse of dimensionality. Again, so maybe I can turn this question to back to you, since you already had some machine learning courses. What is the essence of curse of dimensionality in machine learning AI? So what does it mean, the dimensionality here? What is dimensionality in this case?
Number of features that a sample has.
Yes. And what is the problems with this? What is the problem with this number?
The bigger the number of features.
So what is the logical change here?
You define a function based on the features, so the bigger the number of features, it's harder and takes more time to find a function that actually interpolates all of those values.
Exactly. No, exactly. So exactly. So the data that we collect, so it's always incomplete. So depending on how many variables or features we want to generalize on, so the more data we need. And here we come to this challenge of curse of dimensionality. So again, on this very simple example, so analyzing 10,000 observations of 3 variables each compared to 100 observations of 50 variables each. So in the first case, we kind of sample a phenomenon with good accuracy. In the second thing, we barely sample a portion of it, a small portion of it. Then the complexity, the time complexity. So this is another issue. So it is connected to the number of observations and number of operations which are needed to do processing of data of certain dimensionality. So here are 2 examples of one algorithm with 5 million operations for processing 1 n-bit number, and the second algorithm checks if n-bit number is dividable on any other number. so which requires 2 to the power n over 2 operations. And so depending on n, so here we have an exponential growth in the case of the second algorithm, and which boils down to very, very long execution times. And again, so what is the outcome? So you definitely have seen this this table and this example before. So in machine learning cases, so we do deal with this exponentially growing number of iterations. And as such, so the execution, the time complexity is very, very high, as well as connected parameter of energy efficiency. So let me see. Yes. So let's talk now about learning again on conceptual level. So what does it mean to learn? Memorization. So this is obviously one of the possible modes of learning. However, and this is what the simple models like nearest neighbors models use. So, however, to which extent these models are useful? So, well, they are useful in a way that you can get. I mean, you can deduce similarity of new samples compared to what you have memorized previously, but these models obviously do not allow to generalize on the inputs. So what if we instead, for example, memorize the rules? The rules, and that was still to a large extent is the concept in some schools when you know, even when we learn to solve something, so we learn the rules. So the problem with this kind of learning is that it's very hard to apply this this knowledge to generate new set of rules. Basically, it is well, this step is very, very difficult. So in this course, we will be talking about mainly 2 out of 3 types of learning, which are supervised and unsupervised. I still have an ambition to include reinforcement at some point, but to me it appears quite outside of the scope. I mean, hard to connect to the other material yet. So on the level of definition, it's pretty much understandable. So in supervised learning, we provide system with the correct answers, and the task is to approximate a function. So given an input to produce an output. So unsupervised, in unsupervised learning, so we do not provide any labels or any information about the samples, and let the algorithm to find certain dependencies in the data itself. So here we have examples of such algorithms like clustering, or in this course you will try self-organizing maps. I personally think that this is a very important learning mode because of different reasons. First of all, it gives you insights into the data itself, and secondly, so how data is arranged with respect to each other. And then just to me, it appears to be extremely interesting, the transition from unsupervised learning, which is kind of default learning mechanism, to be corrected by the supervised regime. So reinforcement, well, again, so as I said, we are not dealing with the reinforcement learning, but it's a learning where you give a reward to a system, well, via special function for correctly taken decision or punishment for the incorrectly taken decision. So most of the biological systems they use this learning, but here let me see what I have. So while still being on this slide, I want to comment on exactly this experiment. So reinforcement learning is the well, is the learning mode, as I said. So you are not given labels, but it is still a kind of supervised mode that results in conceptualization. So here, as an example, I chose an experiment with honeybees, which was conducted by my colleagues from Melbourne, RMIT in Melbourne. And so what they do, they study behaviors of honeybees. So I don't know if you have ever read stories about honeybees being able to recognize abstract concepts like above, below, to the left, to the right, bigger, smaller. So this news very often come from that group. And so this study is interesting in several ways connected to this course. Well, so the experiment is about a bee being led in a maze. So it flies through a maze, and so it's Y-shaped maze. And in the beginning of the maze, it is exposed to a visual input. So where the different geometrical shapes arranged in a certain conceptual way are shown. And then inside the labyrinth, so the path leading to the positive reward, so like sweet, something sweet, it has a very similar picture, so same conceptual picture. And so the path towards negative reward shows something totally different. And so these are the experiments that was conducted, and the main finding was that honeybees, they were able to distinguish these concepts. So, for example, above, below, that or certain shape is larger than the other shape on the picture. In only few trials, like 70 trials. And to me, this is pretty much amazing, because very few AI algorithms can really do this kind of fast learning. So that also tells us how, I mean, gives us a baseline to where we are heading to. So how the AI algorithms, learning algorithms, should look like in the future. So so the bottom line is that biological systems solve very complex learning problems very fast and at using the just a fraction of energy which otherwise used by large neural models. Now, at the end of this class, I maybe want to use this opportunity and introduce a little bit my own area, and because you will be working with this theory or these methods in one of the labs, and I personally find it very suitable, just specifically in the context of this course. So if we just consider a landscape of artificial intelligence, so you know that there are two approaches. So historically, two approaches. So it is all started with a symbolic approach. So basically, an approach which relies on logic that models knowledge, and knowledge is organized on through a set of rules. And the second approach to AI, which is called connectionist approach or neural network based approach, in which intelligent functionality is attempted to be modeled through imitating representations of brain in form of neural activations. So historically, so one of the approaches were dominating over the others, and then they were swapped. So now it's time of more of neural networks, also with the tendency to go back to the symbolic domain. So I don't want to go into lengthy discussion in differences. So basically, both approaches, they have pros and cons. So symbolic approach, it really uses it does fantastic job on representing knowledge and performing reasoning. So using solid mathematical foundation. On the other hand, so the downside of symbolic approach is the grounding of symbols. So basically, so the symbols that symbolists consider, so they are just drawn out of thin air, and there is no connection to the actual phenomena if a system would be placed in the environment. On the other hand, this connectionist approach, and connectionist means that really refers to connections between neurons to model certain cognitive or intelligent functionality. It doesn't have this problem. So all the representations that are learned here by neural networks, they automatically grounded. So because you learn on the actual samples of reality that's your agent is exposed to. But the problem is what to do with this representations later on. So how to form more complex concepts and how to integrate them into reasoning. And so there is a still ongoing research about the neurosymbolic integration. So the several methods exist. And so one of the methods that's or one of the theories that I'm working on is called vector symbolic architectures, where you have a computational system which works on high dimensional vectors. So, and vectors have dual nature, so they can be used as symbols. So, you can form symbolic representations, virtually creating any data structure with the help of algebraic operations. And at the same time, they exhibit the connectionist nature. So basically, you can interpret each vector as neural activations. And apparently, so this kind of representations are very, very suitable for this novel type of hardware, like hardware which is based on spiking neural networks. So we have an ongoing project with Intel, where we try to implement unsupervised learning using this computational techniques on their spiking microprocessor. Or yet another type of hardware which has been developed in IBM, which uses a different principle. So it uses the principle of computational memory. So or computing memory. So one of the bottlenecks of current computers is this bottleneck between the memory and the processing unit. So where you need to shuffle the information back and forth. So one of the approaches, again, to create a hardware which is adapted to AI needs is to create memory with certain computational capabilities. So, and this approach, this computing framework that we are working here is also compatible with that kind of hardware. Yes. And that is basically it for the introductory part. So let's meet tomorrow and start talking already about some technical stuff. Any questions? No? Good. Then see you tomorrow.